You cannot see it with your naked eye, not even in an optical microscope, but I can promise you this copper foil is covered by one layer of graphene. In fact, if you could see it, I wouldn't be satisfied.
When Andrei Geim and Konstantin Novoselov won the Nobel Prize for their work on graphene in 2010, they had used a method that was as simple as it was brilliant. Adhesive tape had been used to peel off a piece of graphite, capturing thin flakes of carbon, some of them only 1 atomic layer thick. That is graphene. Chalmers University of Technology has been honored to coordinate one of the European Union's biggest ever science project, graphene flagship, and time has come to take the supermaterial out from the research labs and into everyone's lives.
As we are speaking, there are more than 100 research groups all over Europe working on applications of graphene, and samples like mine are their raw material. This is why you should not be able to see my graphene. High-quality graphene is almost totally transparent.
The method Jie Sun and his colleagues in the Quantum Device Physics Laboratory used to fabricate graphene is called CVD, chemical vapor deposition. This method and the state-of-the-art cleanroom facilities at Chalmers opens up for scalable and high-performing solid graphene samples. The CVD process revolves around a piece of copper foil, which is used both as the catalyst and substrate on which graphene is grown. The 50 micrometer thick copper sample must first be cleaned. After passing a few baths of different chemical solutions, such as acetic acid and acetone, the sample is finally blown dry by nitrogen gas. The foil is then loaded into the CVD machine. In a fixed position, it will now be heated to a temperature just below the melting point for copper, about 1000 degrees Celsius.
And then we introduce some gases. They contain carbon, such as this one. It's called methane. At very high temperature, these carbon gases will become graphene on top of the copper.
Due to graphene's unique properties, it is predicted by many to become the next big thing in technology. And it comes at a time when the world is crying for more sustainable solutions. Jie Sun and his research colleagues are at the moment focusing on 3 of the superpowers of graphene: its transparency, conductivity, and flexibility. We use materials with these properties daily. The displays on our smartphones are transparent, and our fingertips can control them due to their ability to conduct electrical current at the same time.
Most touchscreens today use ITO, indium tin oxide, and indium is a very scarce material. It is listed among one of the most critical metals in the world. If we could find a way to produce such displays with graphene instead, then the raw material will be carbon. Remember, carbon is the 4th most abundant element in the universe. Imagine in the future, your flexible smartphone can be worn on your wrist. And when you don't need it, you can throw it in your garbage bin without damaging the environment.